Hello, and welcome to the live stream for Firefly Alpha, which is a new rocket which is being developed by the company Firefly. And this is going to be their first rocket, which hopefully will be getting into orbit. Um, the Firefly Alpha is, of course, a small sat launcher, which is specifically looking at getting payloads below 1 ton into orbit. And Firefly is an interesting company. They have some interesting ideas and interesting concepts around trying to lower the cost for access to orbit. So, of course, we at Astra are very interested in what they have to say. I'm the chief engineer at a student group called ASTRA, just to tell you a little bit about myself. And we are, of course, trying to build a rocket which will go to the Kármán line. Yeah, if you want to know more about that kind of stuff, you can go check out our channel. We have a bunch of videos about our path that we're going down to try to build a rocket which goes to space. We have a little bit less resources than Firefly, unfortunately. They have, some hundreds of billions at their disposal, but we're trying to get by with just, the resources of a student rocket group. But we're always looking to the professionals and people that have done this path before for inspiration as to how we go about designing our rocket. And actually, there are some similarities that are between the Firefly rocket and Transcendence because they're actually both built out of carbon fiber, which is, of course, one of the lightest materials that you can use while still having structural integrity and getting those good mass ratios that can get you into orbit for potentially less cost, depending on how you set up the system, of course. Just to give you a little bit of an update on where we are in terms of the lead up to the launch. We are at T minus 15 minutes. You can, of course, see that in the top right-hand corner. I have a clock there. We are going to be switching to the live stream once we get a little bit closer to the launch. Right now, the vehicle is on the pad and is fueling up. The oxidizer is just about finished loading, and I believe the fuel has already all been loaded. So that's where we are right now. And there was a little bit of a question around whether we were going to be good for weather. Of course, there were some higher level winds coming through the area where they're launching, which is out in California. That tends to be something that happens in the later parts of the afternoon at this time of year. So, but so far, everything's all go. They say that the wind is going to be no problem this time, and we should be seeing a launch in a little under 14 minutes here. But before we get into the whole launch process and actually seeing the launch happen, we kind of want to first understand what's going on with the launch. So I think we should go over a little bit of what's new about this vehicle, how it potentially fits into the small sat launch market, and exactly where we're expecting this vehicle to, like the expected sequence we expect this vehicle to go through as it's going up into the launch. Because we want to know if this vehicle is actually working as we watch it. And we want to know a little bit about, how it's going to get to orbit in general. So, we might as well just start up with some vehicle stats. So the Firefly is a bit of a bigger small sat launcher. Just to give you an idea of the approximate magnitudes, one good example to compare it to would be the Electron, which is Rocket Lab's rocket, which is a small sat launcher. Rocket Lab's Electron stands at about 18 meters tall, but of course Firefly is here standing at 29.5 meters tall, so it basically towers over the Electron vehicle. They're both built out of carbon fiber, so they're kind of comparable in this sense. The main diameter is about 1.8 meters, which is again about 50% bigger than the Electron. And that gives them a lot of volume to play with in that payload fairing up in the top there. And it also gives them quite a bit more payload capacity. Right now, their listed capacity is just over 1 ton to low Earth orbit and 745 kilograms to sun synchronous orbit. That is going to put them in a weird situation where they're kind of on the border between a small sat launcher and a medium sized launcher. So it's kind of an interesting place that they've put themselves in, and it seems like they're anticipating that satellites are going to get a little bit bigger in the near-term future. And it seems like that's kind of the way the industry is going, so that might be a good bet for Firefly. But we'll see more on that later. Of course, this is a two-stage rocket, so it's going to have a booster on the bottom there, and then the very upper third of the rocket is the second stage, and that's going to take the payload fairing and well, what's inside the payload fairing anyway, all the way into the orbit. So you're going to see a staging event that happens about 2.5 to 3 minutes in the flight. So look out for that. So what is powering the Alpha to orbit? Well, it basically runs on the standard formula, RP1 and liquid oxygen. This seems to be pretty ubiquitous amongst a lot of the launchers that are coming out these days, just because it's kind of one of the simplest formulas to play around with. You don't have to worry about the complexities of dealing with like hydrogen and methane. Those tend to be a little bit more difficult. RP1 is just a liquid at room temperature, so if you want to reduce complexity, it's usually a good way to go. It's also quite a lot denser than hydrogen and methane, which is a whole other complexity that comes when you try to get a little bit fancier just to get a bit more specific impulse. RP1 LOX do have a little less efficiency in that sense, but because of simplicity, the small sat launchers tend to utilize this type of formulation. The thing that is powering the Alpha is basically these 4 Reaver engines. You can notice maybe where the Firefly gets its name from. If you ever watched the show Firefly, you'll know that, of course, the main ship is called Firefly, and the bad guys are the Reavers. So in a way, the Firefly is being powered by, I guess, the bad guys from the show. I don't know. But basically, it's running on what's called a tap-off cycle. This is really interesting because the tap-off cycle is not such a common cycle that's used in rocketry for orbital class rockets. I don't believe there's actually ever been an orbital class rocket that has used a tap-off cycle. So if this does actually make it to orbit, it'll be the first one. In terms of its overall performance, it gets quite a lot of thrust at 730 kilonewtons or so. And so that's why they only use 4. That is a little bit weird as well, because usually small sat launchers tend to use like more engines, kind of for redundancy in case there's a failure and stuff. But Firefly just uses 4, and that's, I guess, good enough for them. What this does, though, is it prevents them from being able to deal with engine out capability. So if one of their engines goes out, that's basically it for the rocket. There's no recovering after that. So it'll be interesting to see if that gives them any issues in the future, because it has given them futures. It did give them problems last time, because this is actually the second launch of this rocket. The first time they launched, they actually experienced a failure. And what really happened there is that a valve basically shut off and cut off the flow of fuel to one of these Reaver engines, which means the engine shuts down, and they basically didn't have enough thrust to recover from that. And on top of that, the way that this rocket actually orients itself is by using vectored thrust, but these rockets only vector in one axis. So essentially, if they actually lose one of these engines, they lose the ability to vector their thrust in one axis, which means that they don't have full coverage, and then the rocket can't really balance itself out anymore. So it really means that everything has to go perfectly. They can't have a failure on anything related to the engine, otherwise they could be in some big trouble. So we'll see if they're able to get it right this time. But it seems like they've fixed those problems, and hopefully they should be in a smooth sailing condition for this launch this time. And of course, as I already mentioned, the material of the tanks is all CFRP, which is seeming to be a more popular choice these days. Although, in the past it might have been more difficult because of expense, but carbon fiber technologies and manufacturing with carbon fiber is becoming a lot cheaper today in the world. Even so cheap that sometimes students can play with it, like we are. So just to show you a bit about the tap-off cycle, what makes this special is basically that they're taking the exhaust gases from the combustion chamber and actually using that to run the pumps that pump the oxidizer and the fuel into the combustion chamber. So this is a little bit of a curious way to do it, because usually the combustion gases are quite hot, like 3,000 degrees Celsius, 4,000 degrees Celsius kind of hot. So designing a pipe that can carry that kind of gas is usually quite an engineering challenge. Typically, you just use some sort of like pre-combustion chamber where you can kind of control the temperature of those gases and kind of make it easier to work with and pipe that into the turbine that runs the pumps. But this is, of course, maybe a bit simpler because you remove that need for a pre-combustion chamber, and you can just simply have a pipe that gets the work done in the same way. So again, the whole aspect of this vehicle is kind of geared towards making it simple and trying to engineer the solutions that will achieve that essentially. Finally, we just have the upper stage here, and of course it's kind of a similar structure to the booster, just a lot smaller. And they have a engine that's about about 1/4 the power of the Reaver engines on the bottom. So essentially, this is what carries them the rest of the way to orbit. It runs on the same fuel and oxidizer, and same CFRP material is making the tanks and everything. So super simple rocket, at least on the outside. Of course, it's quite complicated on the inside, but it's just another one of these small sat launcher designs, kind of on the edge of small sat, medium sat. The stages to look for in the launch sequence are the following. So first, we're going to, of course, have the liftoff at T-0 seconds. We should see the light up of those 4 reefer engines, and we should see the booster taking off nominally from the launch pad with some loud thunder, good engine roars. Then after about 2.5 to 3 minutes, we should see the separation of the booster from the second stage. And of course, this is not a reusable vehicle, so it's just the booster will just fall back into the ocean. The launch is going to be going towards the west from California at the Vandenborg Space Force Base. And this is a bit curious of a orbit to be going into, but they're basically doing this so that they can for sure launch over water. If they were going to the east, they would of course be going over land. The reason why you tend to want to launch things east is because you want to use the rotation of the Earth. But in this case, they have such a small payload that it's okay that they can go west and not take advantage of that little bit of a kick. So we will see the rocket going off into the ocean direction, and we should see the separation event with the booster coming back down into the ocean. The second stage will, of course, light up and then carry the payload all the way into orbit, which we should see relatively quickly after the booster separation. We should see the ignition of the second stage. Relatively quickly after that, I think it's maybe 10 or 15 seconds after that, we should see the deployment of the payload fairings. Of course, you don't want to carry those all the way to orbit because that's extra mass that you don't need. And getting rid of that will help you get towards your destination, which is orbit. And then finally, after about a 5-minute burn or so, we should see orbital insertion, and we should be hopefully having a successful mission. All right, let's get back to the live stream and see what's going on at the launch pad. And it looks like we're having a bit of a difficulty. Just give me 1 second here.
This is a very big thing here that started. T-minus 2-minute poll.
Chief Engineer,
Send it.
Launch Director,
Go for launch.
Rock,
Range green.
12.21 confirmed, buying off. T-minus 1 minute and 50 seconds.
All right, we're almost there.
I can't believe this. They're going for it already. Like, how are they doing this? I mean, we are T-minus 1 minute 30 seconds.
So it looks like they're going straight for the. It looks like they're going straight for the start of the launch window here. So they have a 4-hour launch window that starts in about a minute and goes for 4 hours. So it looks like they're just gonna go for the right now, just launch the rocket. Usually for these test launches, like they take their time and sometimes they delay for 30 minutes, maybe delay for another 30 minutes and get somewhere in their launch window. But it seems like they're just gonna go for it. So this is interesting. I'm also loving this camera from the bottom of the rockets. This should be pretty cool if they show it at the start of the launch. So you can see there are still some gases escaping from the rocket, and that's just the liquid oxidizer. Of course, it gets loaded all the way right up to the end because it's loaded at cryogenic temperatures, and so that actually it needs to be constantly replenished.
Tank is maintaining between 30 and 36 psi. Verify all other tanks are vented.
So it looks like we just got an abort condition.
Is it below 100? We'll keep. Go ahead. Please open TV 605.
TV 605 open.
I guess I spoke too soon.
Verify that the TVC tank is vented.
I was excited to see this go, but okay.
Verify swim system is vented and cavity purges are active.
Is it good?
VC, please verify the C reos in the release safe state.
Sounds like a burst case.
VC, please confirm C reos in the release safe state.
So this looks like the computer automatically triggered the abort,
I have save on the.
and they're just trying to figure out why.
So you guys are hearing there, we are, you guys have heard that they have gone for they've called an abort, but again, they have a 4-hour launch window here. So that was right at the top, right exactly at the top of their launch window. They called an abort. And actually, again, this is only their second launch attempt ever. So, there's a chance that they have an opportunity to reset, and hopefully we still have a chance to fly today. We will await a new T0 time here for you guys, and we will get you guys updated on that as soon as we know anything. But currently, we are back in a hold, which means our teams here get a chance to breathe a sigh of relief because we are definitely running the scramble game. But yeah, holy cow! I thought, oh man, my heart was racing. My heart was.
So that's too bad. It looks like they're gonna have to do some sort of reset here. I'm not sure exactly how long that's gonna take, but it could be that they can reset. Of course, they have the full 4-hour launch window today, so it could be that they can reset the vehicle and try to go for a launch again. It's always a bit dicey with these things, especially when the computer calls the abort, because it's not always immediately clear why it called the abort. So the engineers are going to have to go through the data to see what exactly was the trigger. It could have been anything from a valve or just a temperature spike or a pressure spike. Anything like that can kind of tell the computer okay, no, shut down, don't launch today. So they're going to go through that data to see if it was actually a useful abort condition, or if it was just something weird that happened and maybe they can just push through it. Of course, with these new vehicles, there's always a lot of those little conditions that are kind of there but maybe not necessary, and so this is kind of the stuff they have to look out for. But don't go away yet. There could be a chance that we still launch this rocket, so not to worry.
For minute T0 right at the top of their launch window, a date that they've had in the books for months. That's impressive. That's genuinely impressive. So, yeah, thank you again to everyone for watching. Hopefully we learn more and more here, and we'll update you guys as soon as we can. But meanwhile, we want to give you guys a few extra questions here. So this is from Budarowski saying, Tim, what's the difference?
So maybe in the meantime, we can take a little bit of time to investigate what kind of payload they're actually putting onto the rocket. So this is actually one of the payloads that's going on today, which is called Serenity, which is, of course, another reference to the Firefly TV series. So it seems like they're really jumping on board with these references. But basically, this is a CubeSat, which is 3U, which just means that it has like 3 of those 10 by 10 by 10 centimeter boxes on it. And it has a bunch of science payloads and stuff for measuring things like radiation. And it also has an onboard camera, which is going to face the Earth. And it's basically made by the Teachers in Space Foundation. And they're dedicated to trying to bring space-related things to regular everyday people. Especially to students and into the classroom. So definitely a really cool payload to have as part of your test launch. And looking forward to seeing that fly and give some useful data and help people learn and connect with space. And yeah, we'll, of course, don't mind the T-minus clock anymore. We're going to be, of course, running a little bit by the seat of our pants here. It'll depend exactly on when they decide to tell us information about where they are in terms of the abort condition, because it could be that they recycle and come back. So don't run away just yet.
To support Antares as well. So, are there cameras, onboard cameras on this rocket? Yes, there are. There are cameras on board the rocket, and yeah, that's something that's obviously pretty cool. We aren't able to show all of them, but we can show some of them, and at particular times we'll be able to do exactly that. So, yeah. This is from Corey S. Thank you so much. I appreciate your chat saying, welcome to Cali, Tim and crew, pointy end up, flamey end down. It's so fun seeing that that we actually have the cameras out here to really give you a good confirmation. Yeah, how cool is that? Let's see. Yeah, this is, I love. Thank you so much, Mike Jennett. This great broadcast, Tim. Big shout out to Firefly team for all the hard work at ASTRA. 100%. Again, space is not easy, and we're seeing them knock it out of the park so far, just even getting this vehicle on the pad and fueled up and going for a launch attempt this early on. Very, very impressive. This is cool. I love seeing these kind of comments. This is from, I'm going to totally not say this name correctly, but Wissiv Rees says, hi, Tim. Thanks for inspiring me to pursue a degree in aerospace engineering. That's what this is all about. That's what Everyday Astronaut's all about, bringing space down to Earth for everyday people. It's just helping you guys get excited about this stuff. For me, like, literally, if I didn't have a YouTube channel and a weird van that does 4K broadcasts, I'd be out here just totally nerding out. I would have probably a same tent and or an umbrella and a lawn chair, watching rockets fly and just screaming at them by myself. This is my opportunity to be able to share this with you guys. Hope you guys come along for the ride and hopefully enjoy this as much as I get to enjoy it, which is an immense amount. This brings me so much joy. Seeing a rocket fly is one of my absolute favorite things. But what's even more exciting is when you learn how they work. When you learn some of the details that engineers get to, the problem solving they get to do, the little bits here and there of like all the little secrets of you know, even like things like liquid oxygen. It's just insane to me that there's fuel on board this vehicle that's so cold. You know, if you went up and touched the side of the rocket right now, your hand would like stick to it because it's so cold. Just all these amazing facts and things about spaceflight get me excited, and the more I learn, the more I appreciate the how hard people work and how brilliant people are. There's humans out there that are just so insanely brilliant, I can't even comprehend, and to be able to problem solve and make.
So we're going to go into a bit of a pause here as we wait for information as to what happened with respect to the abort. And if they decide to recycle, then we'll quickly jump back on and give you coverage of what was going on. But in the meantime, yeah, just look to either official channels, or you can stay on the stream and just see if we start back up again. I'll keep the condition in the top right hand corner of what the status is. And so yeah, see you later. So it looks like we are actually going to be seeing a launch still potentially today. They've reset the clock for T minus 50 minutes or so now. So we should be seeing a potential recycle for this and hopefully a launch. So I'm guessing it was probably just a switch or something that didn't quite do the right thing. Maybe they had a valve issue. Who knows what the heck happened? But clearly it wasn't so important that they had to recycle the entire rocket, and now they can just reset and hopefully fly again. So we're going to be about 49 more minutes here. In the meantime, we can, if you have any questions or anything about the launch vehicle, or questions about what the mission's all about, or what Firefly is about, please feel free to ask. I think I'm going to run through again what we expect how we expect the whole launch to progress, and a little bit about the vehicle itself, just for those who have maybe joined a bit later. Of course, today we're going to be witnessing the Firefly launch. This is a test launch, so everything is kind of on the testing schedule. So we could see more delays even after the one that we just saw. Something happened in the last minute and the computer basically triggered an automatic abort. So we're of course waiting for that to recycle. Firefly is a new vehicle that's being developed, and the Alpha is essentially going to be in this role between a small and a medium launch vehicle. So it's going to be able to get about 1 ton of payload into orbit for its maximum capacity. Of course, today it's not taking that much. It's just taking 35 kilograms and some just small, test payloads, basically as for demonstration purposes that the vehicle works. They've never actually gotten this vehicle to orbit yet. They did have one trial run about a year ago, which didn't go so successfully. Unfortunately, they lost one of their engines on the way up, and they didn't have enough thrust to continue on the way to orbit. And they also lost control when they ended up going through the Mach barrier, because they only have gimbal range. Each engine is responsible for one axis of gimbaling, and if they lose one engine, basically they lose controllability. So this is why their last launch failed. But we're hoping that these issues have been solved and that basically we are going to see a successful mission today. So a little bit on how this launch will unfold, just to refresh your memories. So of course at T-0 we will see the liftoff, assuming that we don't have any more issues with the abort conditions, of course. This will of course hopefully be pretty exciting. We have a bunch of cameras. The people who are hosting the live stream have a bunch of cameras all over the site in really cool places, sometimes like right underneath the engine bells. They have one like that's looking through the side of the flame trench. They have like a couple of tracking cameras that are all around the site. Firefly is super open with, just letting people see all of their cameras. They're not like having too many restricted views where you're not allowed to see stuff. So it should be pretty exciting to watch all come in live. So looking forward to that. After about 3 minutes or so, we should see the separation of the booster stage. This separation is, of course, because the vehicle is a two-stage vehicle. So the booster does some of the work, gets the rocket into space essentially, but then the second stage has to take over and get it into orbit. Because it's not just about getting into space, you also want to get your payload into orbit, which means you're going to need a lot more horizontal velocity. Also a reminder that this is, of course, a small sat launcher, so it doesn't really have a reusability in its plan. Hopefully in the future that starts to become more of a priority for companies. I think that that's really kind of important for pushing the industry forward. But for now, of course, this is a very new vehicle, so and it's also in the small sat category, so reusability isn't such a priority. So they will not be reusing the Alpha. The booster will fall back into the ocean and become probably a reef or something for some fish or something. The second stage will, of course, carry on. It will light its engine only a couple seconds after the separation, and that will be what carries it the rest of the way into orbit. Some seconds after we see that ignition, we're also going to see the separation of the payload fairing. The reason for this is that the payload fairing is essentially protecting the payload from the aerodynamic forces as we go through the ascent. But once you're out of the atmosphere, there's no longer a need for that payload fairing. You're just in space, and it's just basically dead weight. So you try to shed that dead weight in order to allow you to continue moving to orbit and get a little bit more efficiency. And then finally, after around 10 minutes of operation, we should see the orbital insertion. In this case, for this mission, they're going to actually go into a parking orbit, and then they're going to circularize their orbits some, I think it's like 45 or 50 minutes later. So that's just kind of the sequence they'll go through. And then, of course, they will deploy their payloads after that, and then that'll be the end of the mission. Just to give you a reminder of the payload that's actually on board, there are a couple of little missions on board, but the one that I think is the most interesting is this Serenity payload, which is, of course, aptly named because everything is kind of named after the Firefly series stuff. So I don't know if you've seen that show. Yeah, basically all of Firefly's stuff is kind of named after that. The Serenity payload is basically has a bunch of science on it that's measuring things like radiation, and it has a camera on board, and it has other couple of things on board that students can interact with, and it's built by the Teachers in Space Foundation. So it's providing an opportunity for people to, students specifically, to connect with students and connect more people to the space industry and space in general. And of course, we at ASTRA here are all fans of seeing more of that. All right, so that's the basic rundown of what's about to happen here in 45 minutes or so. So we're looking forward to seeing that unfold successfully. In the meantime, again, if you have any questions, please be sure to ask. I am a space engineer, and I'm working here at ASTRA as the chief engineer, where we're working to try to build a rocket that goes to the Kármán line. So I do have a little bit of experience with various rocketry systems, and I can answer some of the engineering related questions when it comes to rockets for sure. But yeah, just to give another rundown on the vehicle itself though, because there are some interesting things about the makeup of the vehicle that certainly will help it be competitive in the next coming years. So maybe we just quickly go over those. So in terms of the scale, the Firefly is quite a large vehicle. As I said, it's kind of bordering that edge between being a small sat and a medium sat launch vehicle. It has a payload capacity which is quite large, of just over a ton to low Earth orbit. Usually under a ton is called small sat and over a ton is called medium, so it's like right on the edge there. It's also quite imposing. It stands at just under 30 meters tall, which is nearly double the height of much of its companions in the small sat lift market. Of course, Electron stands at about 18 meters. I think the ASTRA Rocket 3 stands at like 20 meters or so. But that rocket's being discontinued, so don't worry about it. In terms of the overall makeup, though, it's pretty standard in terms of having a two-stage approach, having the first stage be the booster, second stage carries it to orbit, with the payload fairings separating after that. It's all like pretty standard for the industry. What is interesting about the vehicle, though, is it's composed entirely of carbon fiber, kind of similar to the Electron rocket, but of course on a much grander scale because the rocket is nearly twice as tall. It is, I think, the biggest fully carbon fiber rocket that currently flies. So if it does get to orbit, it'll be holding that title as well as being the biggest carbon fiber rocket to reach orbit. The advantage of carbon fiber is that it is significantly more weight effective. So essentially it's has a better strength to mass ratio, which means that you can actually get away with having a lot less of it and still keep the same strength. This means that the tanks will be lighter and you actually get less dead mass coming along with you into orbit. So it's really a game changer in terms of optimizing your mass ratios. which means that you can actually build a smaller vehicle for the same types of payload that you would otherwise be able to manage. And, this can be a bit of an advantage over traditional materials like steel or aluminum, because if they wanted to lift this much payload to orbit using those methods, they would, of course, need a much bigger vehicle, at least in theory. So this is kind of how they're going to compete in the market that they've kind of sectioned out for themselves. To give you a little bit more in-depth views into what's going on the engine side, of course, we have these Reaver 1s. There's 4 of them. They will be powering the vehicle into in the booster phase of it anyway, into orbit, and they run on just the standard liquid oxygen and RP1. RP1 is basically a refined version of kerosene. And the reason why this is commonly used as the fuel is because it is, first of all, quite simple to acquire. I mean, it's like the standard rocket fuel among all the rocket industry. And it's kind of a small step away from kerosene, which is used for all aircraft. So in terms of its cost, it's actually pretty cheap. It's also really easy to work with because, of course, it is a liquid at room temperature, which is a huge game changer in terms of being easy to work with in rockets. The alternatives would be something like hydrogen, which is definitely not a liquid at room temperature, and you have to cool it down to like minus 250 degrees Celsius to make that the case. So that could be a real pain in terms of designing systems to be able to handle that. So, of course, Firefly Alpha is trying to be as simple as possible and remove all of that complexity in order to create the best possible launch vehicle that they can. In terms of the liquid oxygen choice, I am fairly confident. I think nearly every single rocket in the small sat industry right now is using liquid oxygen as their oxidizer. So I think this is just a pretty normal choice to make. You do have to cryogenically cool liquid oxygen, but it just gives you, it's just the best oxidizer in terms of its ease of getting it. I mean, you literally just have to cool down air and you have liquid oxygen. So it's just a matter of the cost that it takes to cool down the actual propellant in order to create liquid oxygen. The other alternatives would be using other types of fuel and oxidizer combinations like hypergolics and stuff, and those can be nice in terms of their performance and stuff, but in terms of ease to work with, really bad, because they basically eat away at your materials. You have to use special materials to be able to resist them and stuff. So even though you might get some performance enhancements or something like that, in the end they usually don't end up being worth it. So that's why all the small sat launchers will typically just be using RP1 and LOX. Anyways, that was a bit of a long tangent. The Reaver 1s will of course be running on that. What's interesting about them is that they run on a tap-off cycle, which is a bit unique in the rocketry world, because it's not common that you would basically be taking exhaust. Like, what tap-off means is you're taking the exhaust from the rocket and piping it into the turbine that spins your pumps. So let me just show you this diagram here. So you can see here that literally you are taking the products of the combustion and you're taking it back in through the turbine, and then that's spinning your pumps that push the oxidizer and the fuel into the combustion chamber. In theory, it looks like all super simple on the page, right? Like, oh, no problem. But that tube that's taking the combustion gases from the combustion chamber to the turbine, it's taking those gases at like 3,000 Kelvin. Or like over 3,000 degrees Celsius. That's for you Americans, that's like 6,000 Fahrenheit. So really, really hot. There's not many materials that can handle that kind of temperature. So yeah, designing a system that can handle that is usually a bit complex. So even though the piping and the plumbing is super simple, yeah, you do have to do a little bit of engineering in terms of the materials. The only other rocket that actually runs on the tap-off cycle that I know of is the BE-3, which is the one that powers the Blue Origin New Shepard vehicle. It's not an orbital vehicle. It just does the, up to the Kármán line and back with the passengers. So there is actually no tap-off cycle engine that I know of that does orbital launches. So Firefly Alpha would be the first rocket to be able to do this. So we'll see. We'll see if they can pull it off. Tap-off might be a more popular choice in the future because I think that the materials problem in terms of working with the combustion gases is kind of starting to be solved. So we'll probably see more tap-off cycle engines in the future just because it is simpler in terms of the plumbing and stuff. So like if you solve the temperature problem, you're like 95%, you're most of the way there, right? The rest of it is, standard rocket science. So then finally we have the upper stage, which is also powered by RP1 and LOX. So it's basically just a miniature version of the booster. And it's powered by one Lightning 1 engine. And this is basically, again, just a scaled down version of the Reaver. It's also running on the tap-off cycle. And it just gets slightly better specific impulse because it has a vacuum optimized nozzle. Of course, you do that. What that means is you just make the nozzle a little bit longer and getting much, much wider. And that is to help expand the gases out to the lower pressure of the space environment. You can't expand the gases so much in the atmosphere because if you expand them so much that the gas coming out of the nozzle has less pressure than the ambient atmosphere outside, you get problems with stability of the flow and you can actually damage your nozzle. So this is why you'll always have less specific impulse on your sea level engines than you do on your vacuum engines. So yeah, anyways, the difference between Lightning 1 and the Reaver is basically slightly scaled down, and they make it so that it optimizes for vacuum. And of course, it's also all made out of carbon fiber, just like the booster. So we are just coming up on 30 minutes now from the launch. So hopefully we're going to see some action here coming up real soon. We'll just switch over to the mainstream here and see what's going on that end. Maybe we'll get to see some of the cool views of the camera.
The system. That obviously isn't going to be happening when something's being pumped, forced out of a tank. You have to backfill and provide gas back into those regions so the tank maintains pressure, so you don't have the tank getting like crushed or anything like that, because that's actually what would happen if you drained it without backfilling it. So they backfill it with helium, and helium is good for a few reasons. Number one, it's inert, meaning it will not react with the fuel or the oxidizer. It will not cause any problems with combustion. And the number two reason is it's extremely.
So you can see here that the vehicle is still filling up with liquid oxygen, and you know that because of the gas clouds that are coming off the top of the vehicle there. That's not indicating a problem or anything. It's just because the oxygen is of course stored at like minus 190 degrees Celsius. So because of that, it's constantly heating up. And when it heats up, of course, it gasifies and then kind of creates a whole bunch of pressure. And the tanks can only take so much pressure. So then the valves on the top kind of release the gas to make sure the pressure stays low. And of course, when you do that, you lose some liquid oxygen, or I guess gaseous oxygen. And they have to constantly top off the vehicle as it sits there with all the liquid oxygen. And it's been sitting there for a while. So now it's been there for an extra hour. So, they have a rate in which they kind of just go through this liquid oxygen because of that. Yeah. There are other things you can kind of see around their launch tower here. Like this is a very simplified launch setup, I would say. Like they don't have any complications here at the launch site itself. Like the tower is super simple. You just see the tower there. It literally just has connections for loading the propellant tanks, and that's it. Firefly is really trying to enhance the operational side of the launch, which is important because this is actually the part where a lot of the money actually ends up going. In terms of how much money it costs to actually set up a launch and everything, like you're always looking at like hundreds of thousands of dollars for every single launch attempt that you try and make. So if you can find ways to optimize the operational side of the launch, it can really enhance your bottom line, especially when you're dealing with small sat launchers that are usually only launching for a couple $1 million anyway. So yeah, if you compare that to like what the space launch system or the space shuttle needed for the launch tower, and it's like night and day. Of course, that's not totally a fair comparison just because they're so much bigger vehicles, but yeah. Just as a reminder, the launch location today is Vandenberg Space Force Base, which is out in California. It's, yeah, of course, as indicated by the name, it's actually a part of the Space Force complex that they have down there, and they have a whole bunch of launch pads there. SpaceX often launches from there. I believe the Atlas V and the Delta rockets also launch from there every once in a while. So it's quite a common launch location. What is a little bit weird about today's launch is that they're not actually, like, typically you'd expect launches to go like to the east in order to take advantage of the rotation of the Earth. But today they're actually doing the exact opposite, and they're actually launching the rocket to the west, which is a bit weird. Usually in California at Vandenberg Space Force Base, you do the polar launches, so they'll launch like to the north or to the south. That's because that's like if you launch in those directions, you can launch over the water. So it can be a good place where they do those types of launches. Launching to the west is usually not done because you're actually going against the rotation of the Earth, and you actually lose like delta V by doing that. But of course, this is just a test mission, and they only have like 35 kilograms on their payload, where they could be taking like up to 1,000. So they have lots of delta V margins, and they just want to make sure that they're launching somewhere so they can actually launch to the west, and it's no problem. And as long as, like, they have to make sure they go over the water so they don't have any issues with flying over people and stuff. Although I do wonder why they didn't just go into a polar orbit. There must be some sort of like legal reason why they weren't able to do that. Maybe it's because it's like too populated already, so they try to go into an orbit that's less populated.
Reason, this is a developmental vehicle. This is a demonstration of a brand new rocket that has yet to demonstrate being able to get to orbit. This is the second launch attempt ever of this rocket with this company, and flying retrograde from California allows them to fly basically as far away from populated areas as possible. So although they're basically fighting the rotation of the Earth to get into orbit, this thing's fighting, having to run upstairs, like running up an escalator that's going down. That's almost like what they're doing. It's harder to do that, but that way, that's what the company feels comfortable with for their first orbital launch attempts. That's what the range and the FAA and all the people involved in issuing a launch license, that's what everyone feels comfortable with, and that's a great way to demonstrate your ability to get into orbit. It's just simply fly as far away from any populated areas or any things of intrinsic value. So that's exactly what the teams are doing. They're playing it nice and safe. And it'll provide a really good view for us here because we'll be able to watch it come up right over, from my point of view, like right over this mountain here. And then it'll look like it'll go a little bit to my left. It'll fly a little bit south, but a lot of west, and it's going to be really cool. So this is one of our views here, looking at the mountaintop there. Man, it is very windy. We got to apologize for the wind, even though it's crazy, even though we're on some really, really heavy-duty lens mounts and things. No matter how sturdy it is, the wind.
Hopefully that wind doesn't turn into a no-go condition. But so far, the weather has been good. They've not indicated that the weather is bad for the launch. So the wind is not such a problem. The reason for that actually is a bit interesting because surface level winds are usually not such a big deal. Like for amateur rocket launches, usually all you care about is the surface level wind because that kind of determines the trajectory of your rocket. Usually amateur rockets don't have vectored thrust. So basically whatever velocity you leave with on the launch tower, is then added to the velocity of the wind, and that determines the direction that your rocket will take. So ideally you want no wind, because then you can just launch straight up and you should come straight back down. But for a professional launch or an orbital launch, basically you don't really care so much about the surface level winds, because you have your engines which can vector, so you can kind of fight the wind as you go up. Of course, you can only do that to a certain extent, because you waste a little bit of fuel by doing this. So eventually they would run out of fuel margins. You couldn't like launch during a hurricane or anything, but you have a lot more tolerance in the lower level atmosphere to fight the wind there. It becomes more of a problem in the upper altitudes, because you're going a lot faster at higher altitudes. And so especially when you're coming through near the Mach barrier, basically when you're in that situation, even just small angles of attack on the vehicle can cause really big buildups of pressure because of drag, and that can basically tear apart your vehicle. So it's usually the upper level winds that they're more concerned about, because it becomes more critical just because of the sheer addition of the aerodynamic forces that come near what we call maximum Q, and the just after they break through the Mach barrier. It's kind of where the biggest amount of drag gets built up on the vehicle, and that's basically where you have the highest structural likelihood that a upper level wind could cause you an issue, put you into a angle that you don't want, and then rip off the payload fairing and cause structural issues. So usually, if it's windy on the surface, it doesn't really indicate much about a rocket's ability to launch.
The black paint preventing frost formation. Believe it or not, that is not black paint. It is carbon composite. It's carbon fiber. That's basically, I'm not going to say raw carbon fiber, but it is actually a really fine carbon fiber, and it's just carbon composites. You end up with all the composite, the stuff that holds it and binds it together. But if you get up close to the vehicle, you see the carbon fiber strands of it. It's not painted. It just is black because it's carbon composite, which is obviously super cool. Yeah, even in that shot, you can kind of see, thanks to 4K, you can kind of see a little bit of that in the very bottom where it's kind of glinting off the sun, just a little. And actually, right above you can see the clamp arm there.
It's actually pretty cool that you can actually see the carbon fiber. Like, they don't paint it at all. And if you want to kind of see what that looks like, I can actually just grab a carbon fiber part here that we have from our tank. Just give me 1 second. So I have here a carbon fiber part. This is actually a part that ASTRA manufactured for our vehicle Transcendence. And essentially you can see here the different layers that go into when you make a carbon fiber composite piece. So this is basically the same thing that is being launched right now with Firefly. It's the same kind of a layout that they're using. So essentially what you do is you take these carbon fibers, which are like these, it's like thread almost, kind of, and you basically just wind it around some sort of a drum or a mandrel, and you mix it with some glue, and that's what sticks it all together so that you get this solid piece. And the reason why that is so effective is because those fibers, the carbon fibers, are super, super strong. In terms of their strength to weight ratio, when you compare them to steel, it's 10 times stronger than steel. So they can really be quite an upgrade, quite an upgrade from just using standard parts like steel and aluminum. But yeah, if you want to see what it looks like up close, it kind of looks like this. And you can also see we've drilled some holes up here. We're just kind of experimenting on this one, so we hope to have some improvements in the future. But yeah, I think that Firefly's quality is definitely a bit better than ours was. But yeah, I'll leave that there. Maybe it'll stay. Yeah, it'll be good. So you can see that, yeah, it's totally possible to work with carbon fiber even if you're an amateur. And you can definitely take some inspiration from the materials that are being used at the highest level. This is basically what's going to allow us to be able to get to the Kármán line with a vehicle that is not totally ridiculous. Otherwise, we'd need like a 10-meter tall rocket or something. Ours is just going to be 6.5 meters or so, at least in the design that we have right now.
Actually flown some really high inclination orbits from Kennedy Space Center, but they're doing that with these really big dog-leg maneuvers, and because of that, they actually lose performance in the rocket. They can't put as heavy payloads into orbit, so fun little fact there. But Vandenberg has its own limitations. It can't fly eastwardly, so you can only fly basically in the polar corridors. You can basically fly polar orbits only, and or retrograde. So, yeah, if you're launching something into into space, you really are limited here at Vandenberg Space Force Base to what orbits you can get into, and it's just not really as. It depends. It's not really as common to fly sun synchronous orbits or polar orbits. They're good for Earth observation and things like that, and some communication satellites they're helpful. But for the most part, a lot of the satellites we see are launched. If you're going out to geostationary orbit or most low Earth orbits and things like that, and medium Earth orbits are all launched eastwardly. So you can't do that here. You'd fly over California. You'd fly over Las Vegas and Nevada, all these places. So that is not an option. And by the way, we are within.
I don't know if Tim is exactly right that most launches go eastward. I would say that in today's launch market, it tends to be that the polar orbit is becoming more popular because we're developing all these communication satellites, specifically things like Starlink and OneWeb. Like OneWeb's satellites are all polar. A lot of Starlink's satellites are polar, at least all the new ones that are getting launched. They're all going into polar orbits now. They were in medium inclination orbits before, but to serve the whole world, they need to go into these polar orbits as well. Also, Earth observation is always going to go into usually polar orbits because that allows you to have access to the entire world. The Earth is rotating underneath the orbit, remember, so eventually the satellite's able to see everything. It's only the geostationary orbits that you will typically see that will go at basically the eastward direction. And those payloads are getting rarer and rarer because there's a lot of latency when you go up to a geostationary satellite because of how far it is away. And that is kind of not really wanted in the communication world anymore. So you're seeing a lot more of these low altitude constellations, and they tend to be going into these types of polar and sun synchronous orbits. Also, if you just look for like, if you want to make a CubeSat payload or something, and you were looking for ride shares and stuff, like almost all ride shares are all going to sun synchronous orbit or polar orbit or something. Like it's very hard to find one that is truly an eastward launch these days. So I would expect that Vandenberg Space Force Base is probably going to get way more action moving into the future, just because it's like ideally suited for those polar types of launches. But I don't know what the economics exactly are of launching from the Space Force Base there. It could be that like Kennedy is a bit cheaper. That could also be a factor. There's also launch sites that are opening up in America, like in Alaska and stuff, because those also conserve those polar type orbits. Of course, there's a launch site in New Zealand, which has the Electron rocket. That one is also being used for polar orbits. So there's really a lot of these like polar orbit type launch locations that are opening up because of these small sat launchers and the demand for putting satellites into these orbits. So I think the eastward orbit is kind of dying, so to say, as a common direction to be going.
P1 flowing through the engine. Think about, I don't know if any of you have like high-end gaming computers and use liquid cooling. You're familiar with how you can basically put up a radiator, you can flow liquid through the core of the processor, and then back.
So we're coming up now on the launch here. We're nearly, I think we're almost 15 minutes. What does the clock say? 15 minutes, almost in the 15-minute zone. So far everything seems to be going well. We're still loading the oxygen onto the vehicle. As you still see those clouds coming off, that indicates that fueling is still occurring. So everything is going well there. Of course, what happened last time, when I say last time, I mean an hour ago. The launch was supposed to start about 45 minutes ago, and of course we did have an abort condition that was triggered by the computer. Not exactly sure what triggered it. They didn't really tell us exactly what that was, but basically the engineers have decided, no big deal, we try again. So they're going to recycle, and in 15 minutes we might or might not see a launch. Hopefully we see a launch. Yeah, and looking forward to a success. This is the second iteration of this vehicle. It did have a test flight a year ago, which didn't result in a success. They had a failure of the Reaver engine, one of the Reaver engines that's on the bottom on the booster, and that meant that it couldn't fulfill its target of getting the second stage high enough to allow it to get to orbit, essentially. And the reason for that has a bit to do with the design of the rocket. They don't have engine out capability. So if like any one of those 4 engines fails that we're seeing in the picture there, like that's it. The vehicle doesn't go to orbit. And there's 2 reasons for that. Number one, with one engine gone, they actually don't have the thrust to weight ratio in order to keep them going upwards. So losing one is kind of a big deal. The second reason is because the gimbal on those engines, each of them only has one axis of gimbal. So if they lose one of the engines, they actually lose their ability to control the vehicle in some directions, which of course is really bad, and the vehicle can lose control. And the last time it launched, you kind of saw it do this like weird somersault when it hit max Q. Basically what happened is the vehicle couldn't control itself anymore, and so it kind of went into a spin, and they had to abort the mission. But hopefully today we're not going to see any of that. Hopefully we'll see a nominal launch. Everything seems to be going well so far. They didn't have any issues with the engines itself or anything. So as far as we can tell, it's all nominal. The weather is holding up well. We still have some issues with some wind here and there, but they're not upper atmosphere winds, so they shouldn't affect the rocket. More the cameras on the ground and the people that have to handle the wind. The rocket is far more capable of handling the surface level winds, so not a big deal.
So I'm not just yabbing on and on and on and on for hours and hours and hours, but we will get that updated. There we go. We already got it updated. T-minus 2 hours and 51 minutes.
Oh no.
Is our official new T0 time right at the
They
end.
put
of
us
their
into a
4-hour
hold
launch
again.
window. Again, their window opened up at 3 p.m. Pacific time, which I think is +7, so 15, 20.
Okay, it looks like we've just gone into another hold, unfortunately. So yeah, 2 more hours and 51 minutes. That's the latest word. So the window that they had open and available to them goes from basically, I think it's 10 o'clock p.m. UTC until 2 a.m. UTC on the 12th of September. So we are now nearly 1 hour into that window. So basically they've just pushed it all the way to the end of the window, which seems to indicate that there could be something going on with something on the rocket that's not quite nominal, I would say. Of course, the engineers are going to continue to check and work on the rocket, but I would suspect that something is not quite right if they're deciding to push all the way to the end of the window. That's basically the equivalent of like, you know, pushing the problem all the way as far away as possible and seeing if you have enough time to deal with it. But yeah, we'll see.
Andrew, at some point, let's queue up. There is that video that they have about the second launch attempt. Maybe we'll queue that up. Let me know when that's ready to go to air, and I'll answer one more question. I don't remember. I think it was a...
In the meantime, I guess you guys don't want to hear me talk for two hours and 50 minutes. If you do have any questions, do let me know in the comments. We can definitely address those, and anything to do with the vehicle or like rocket science in general, or the mission, or Firefly Aerospace. They're a really cool company that are developing new types of ways to get to space and other types of space technology as well. They have a mission that's going to be going to the moon in the future. Definitely going to be an interesting thing to talk about. So yeah, if you have any questions, do let us know in the comments. And in the meantime, I think we will go into a break here, probably for around 2 hours, I guess, unless there are some pressing updates from the engineering team or any communications that we should be aware of. But we'll just definitely still be with you, just in a temporary hold while we wait for information. But thanks for sticking with us, and we'll see you soon. So just to check in with everyone, basically we are still in a hold here. It looks like we are about. It looks like we're about 2.5 hours away from the second, or I guess it's now the third launch attempts. So hopefully we're going to see this thing launch, but it looks like they're going to need a little more time to recycle the vehicle and they're pushing all the way to the end of their launch window. So basically they had a 4-hour launch window that started about an hour and a half ago. And so we have 2.5 more hours. So they're going right to the end of that launch window. I would say that the probability that they launch is probably, I don't know, 50-50 or so. So we have to bear with the rocket gods here a little bit and let the engineers try to work out the problem that they have on the launch vehicle. They haven't shared exactly what that problem is yet, but I'm sure there's something that is kind of gumming up the works and not allowing the launch sequence to progress as we expect. Probably something that came up with that automatic abort that we had on the first try. So just to recap the sequence of events that have happened to now, they did try to launch at the very start of the window. They got all the way to T-1 minute, and then the flight computer basically called an automatic abort. So there was something wrong with either the vehicle or the conditions or something like that that caused it to trigger that condition, essentially. What that means is not that the vehicle is entirely aborted for the day. If they had an instantaneous launch window, that would be the case, but here they have the 4-hour launch window, so they still have the opportunity to come back and reset the vehicle. They reset the clock to 1 hour after the first attempt, and they basically ran through that clock, and at about T-15 minutes, they again called for a hold, and now we're in the current launch time, which would be the end of the window. So at this point, I would say, yeah, the chances of launching are around 50-50. So take that as you will. This is kind of the way rocket launches go. Basically, especially with new vehicles, there's always going to be a lot of kinks to work out, and they're basically going through this process. And here we get to see it live. A lot of some other companies that are more, I guess, veteran, I would say, so like United Launch Alliance, where they have vehicles that have been flying for 20-30 years, they basically will try to keep this process as how shall I say, undocumented as possible, and they basically will show you the polished product, which is their wonderful launch. But here we get to see all the ins and outs of basically Firefly as they problem shoot on the fly to try to get this launch vehicle into the air. So that's a bit exciting as well. There are a bunch of cameras set up all over the launch pad in cool places like underneath the rocket and in the flame trench, and various tracking cameras are all placed all around the rocket in ways that you wouldn't expect for a typical launch. So it really would be exciting to see this thing take off. Definitely to see at least the camera views. The Everyday Astronaut is streaming this in 4K to the world, so that's definitely a unique vantage point that is not typical, I would say. Usually, rocket companies are prioritizing the engineering side of the data that they get out of the things like the tracking cameras and whatever camera they have on the vehicle. But there's definitely a focus here being placed on letting the public kind of see what's happening. So definitely a cool thing that Firefly Aerospace is trying to do here. If you're just joining the live stream now, basically what's happening right now is the Alpha, Firefly Alpha, which is the primary launch vehicle that Firefly Aerospace is developing right now, is currently trying to go through its second test flight. Its first test flight didn't quite work out. That would happened about a year ago. They had a failure in one of their engines, which caused them to not be able to reach orbit. It kind of ended in a bit of a fireball because they had to trigger the launch abort system, which basically is a bomb that's on the rocket that blows up if there's a problem. So usually these are the most spectacular failures, are ones that trigger that. But we don't want to see that today, so they're taking every precaution and making sure that they go through all the checks and the balances. We have seen a little bit of weather seeming to come in here. There seem to be some clouds that are forming on one side of the vehicle. So far, as we can tell, the weather is still a go, so that's not the problem right now. It is definitely something to do with the engineering of the vehicle itself and something to do with the technicals that is holding up the process. But they're still working this out, and we expect to at least maybe hear some information, or I guess the count will continue to resume. We're expecting about 2.5 more hours of time, going all the way to the end of the launch window. If they do launch, they will probably launch at the very end. So we'll keep an eye on the clock and any information that could be coming from the Firefly team. And we will definitely keep you posted if anything comes up. I'm not going to stay on talking the entire time, just because I would probably run out of things to say. But yeah, if you guys have any questions, do leave them in the chat. I will pop on and ask questions if you guys have any. So please be free to ask anything. I'm an aerospace engineer, so I work with rockets quite a lot. Currently working in a student group right now that is actually building a rocket, which we want to go to the Kármán line. And what's cool is that some of the design concepts that are in Firefly are actually also in our rocket, because Firefly is built primarily out of carbon fiber, and our rocket will also be built out of carbon fiber. Here's part of the tank you see right back here. And I don't know if it looks similar to the one that is on screen. Not quite as big, but similar technology and similar ideology going into the design and the manufacture of this tank here. And surprisingly, carbon composite has kind of had this air of being super expensive, I think, historically, but I think that is kind of going away as we see more of these vehicles, launch vehicles, start to actually be made out of carbon fiber. Firefly is not the first one. Of course, Electron is the first fully carbon composite vehicle that has gone to orbit. But Firefly is certainly a jump up, as it is a much larger vehicle. So, yeah, it'll be interesting to see if even bigger vehicles than Firefly actually end up getting made out of complete carbon composite. Anyways, in the meantime, we will continue to keep an eye on the launch vehicle and on the Firefly Aerospace team. Again, I'll check in with any updates, and hopefully by the end of the launch window, we'll get to see a launch. I'm streaming from Germany, so it's getting a bit late here, but I'm so excited that I will definitely stay until the end. So we'll see. See you soon.
Welcome back. I have some good news for you. The teams have reset the clock for T-minus, well, it's 58 minutes. When I heard the news, it was T-minus 1 hour. They're going for 5:50 Pacific time. I have a hard time saying Pacific, which is just after, I think that'd be like 50 UTC, if I did the math right, just quick at the top of my head. Probably wrong, but yeah, that's coming up in less than 1 hour. But you will notice in that shot, you see some dark clouds, but currently, despite those clouds and despite what looks like could be potential weather violation, we are actually still go. So the teams are go. Weather is go. Everything looks good. It seems like they have resolved the issue that was halting them from continuing on further into the count. We're go, my friends. And with that, yeah, let me know if you guys have any more questions. I'll wait if we have any more confirmation or update on what exactly the teams were working through, whether or not it's just range and weather violations or...
So this looks fantastic. Looks like we're going to have a launch a little bit earlier than the end of the window. So that is good news, I would say. So 55 minutes left to go as they try to recycle this vehicle now for the third time. Hopefully they've solved that engineering glitch that they had well enough that it won't pop back up, and maybe hopefully that nothing pops back up. In terms of the weather, although from one camera view it does look a little scary, I think it's probably going to be okay as long as they don't get any like thunderclouds or something. I don't know, does anyone have an eye on the California weather? Hopefully it'll hold up for another hour or so. Again, just to be clear, it's the upper level winds that are, of course, always the more of a concern. But as far as the range is concerned, the weather is still go. So nothing to worry about there. Of course, we will continue to keep you posted about the status of the vehicle and where we are in the count and everything. In the meantime, we will come back probably at about T-minus 30 minutes or so in order to kind of go through the live coverage again. So until then, stay strong. Hopefully we're going to get to see this launch today. The Firefly team seems to be a bit dedicated to trying to get this up today because this is now, as I said, the third recycle. So it's rare that you see a rocket go through 3 recycles. So that's good to see. And I'm really looking forward to seeing the launch from these cameras that are positioned all around the site. So I hope that you're excited to see that with me too. So until 25 minutes from now, see you soon.
after they deploy something, the upper stage is still in orbit. You know, you're still in orbit, and it's becoming a common tactic to deorbit the vehicle.
So it looks like we are officially at a scrub condition for today. I guess they tried to recycle, and now something else has come up. Most likely, it seems like it was some sort of a violation with respect to the range or the weather. Not exactly sure exactly what it was, but we'll have to keep listening for a little bit here.
Actually going to do. I'm actually going to take just a quick break here myself and await further information before we give you an official statement on what exactly is going on. But stand by for more information. I will let you guys know as soon as I know anything else. Yeah, stand by.
Okay, so not exactly sure what the violation is right now, but they did have activated an official scrub condition. It could be, again, that they're just going to try and reset again. Again, they still have a little bit of time left in their launch window. I believe they still have, as of right now, they have 1 hour and 50 minutes. So it seems like their recycle time is around an hour. So it could be that they're able to, again, recycle. So there is still a chance, albeit a very fading chance, that this rocket could go off today. If it is just a range violation, they could probably clean that up relatively quickly. If it is a weather violation, of course, it's probabilistic, but we'll see. It doesn't look like they have put anything officially onto any of their channels. Usually they update the Twitter pretty quick if they've decided to do something different, so they haven't done that yet. But as soon as we know something, I'm definitely going to let you guys know. For those that are still waiting. The true troopers. The true fans, I guess. Yeah. It's too bad. I really was looking forward to this. This is really going to be an interesting vantage point to watch a rocket launch, just because they have so many cameras set up all around the site. And this is such a unique vehicle in terms of its scale and composition and the style of mission that it's going to be doing today. If you weren't there for the previous updates and about what the mission's all about and stuff, they're actually launching into a really weird orbit today. They're going retrograde. What that means is that they're actually gonna, usually rockets launch like with the spin of the Earth, or they launch into like a polar orbit or something. That basically when the Earth spins, there's some momentum with that, and so it kind of helps you get into orbit because it gives you some horizontal velocity. Of course, if you go against the direction of the Earth, you actually lose some velocity. So today they're actually going into a retrograde orbit, specifically because it takes them the furthest away from land. So this being a test flight, they want to, of course, make sure that they don't hurt anyone, they don't cause any problems. So a little bit curious if they have a range violation, because they're literally flying into the middle of nowhere. Who is disturbing it? Yeah, that's a good question. We have we have an interesting video about why rocket launches get delayed. So if you're curious about that, definitely go check that out. It's not just like, you know, there are the usual culprits like weather and stuff, but there are also other reasons that rocket launches tend to typically get delayed. In this case, it being a test mission, you know, it's probably just the engineering. Yeah, something going wrong with the sequence or the operations or the way they're setting it up. Really could be anything. Rockets are extremely complicated vehicles. There's a bunch of little switches, valves, you know, chambers. You got the tanks. Yeah, it's a lot of complicated elements that are all interfacing and interwinding, and sometimes you don't know things until you do it. And, you know, if this is the first time the vehicle has shown up in this condition on the launch stand, I mean, anything can happen. So this is just kind of the way it is, especially with newer vehicles like this, where this is literally the second test flight, and the first test flight ended in an explosion. So they really want to make sure they get it right this time. Yeah. Scrubs are better than RUDs. So that's always the case. So if we are in a true official scrub, then better than an explosion or a firework in the sky. Well, in the meantime, it looks like we have to wait for a bit longer to get official information. So yeah, if you have any questions about the launch or the vehicle or what's going on here, do let me know. I'll be sure to pop in and give answers whenever questions come. Don't worry about the scary storm clouds. I don't think it was the weather that has pushed this delay. Just because I think it's due to the something to do with the range, I'm suspecting, or the engineering on the rocket. We had a question earlier about what the A on the bottom of the rocket means. Now, I'm not entirely positive exactly what the A means, but I suspect it is indicating that this is the Alpha. So Firefly has this whole like vision for the future about the vehicles they want to build and create. And Alpha is just the first one, obviously. So this booster is the Alpha booster, but in the future they want to build a Beta, which is going to be kind of like this Falcon 9 style rocket. So they're going to have basically 3 cores all stacked beside each other, and then the same upper stage, so they can get more payload into orbit. And those 2 side booster cores will separate like on the Falcon 9. So it'll be kind of similar to that. Except, of course, it won't be reusable. Although, who knows? Firefly Aerospace is considering all kinds of crazy stuff. Maybe they have an idea for reusability already stirring up in the works. Could be possible. In the meantime, we'll continue to monitor the situation with respect to the scrub and get back to you with official information as to what exactly is the problem and when they expect to potentially be launching again. Could be today, could be a couple days in the future. We'll see. In the meantime, yeah, enjoy and stay tuned. So we are still waiting on any official commentary from Firefly Aerospace about what exactly is going on with their launch condition right now. It appears to still be a scrub, and as far as I can tell, I'm not seeing any liquid oxygen leaving the tank anymore, which is a bad sign. This means that they may be in the process of not resetting. Although maybe that was just the camera angle. I still see a little bit of gases coming off the top of the arm there. So maybe she's still fueled up. But I'm not really seeing signs of detanking. So if it was really a full scrub, you would think you would see that. But maybe it has different signals than we usually expect on other rockets. Maybe this is a bit of a unique rocket. Who knows? We need official word, to be honest. But as far as I can tell, the rocket appears to still be like ready to go. If that means anything, maybe that's just me being hopeful, you know. Yeah. That could also be the case. I'm forever the optimist. And it's already 2:30 in the morning here, so I really just want to see a rocket launch. But I have to keep my patience at bay because, you know, it is always better to see a successful launch, and they definitely don't want to have a repeat of the first test flight. So really good to make sure everything's all in order. But if this is really just a range violation, I hope they clear that out quickly and allow this wonderful vehicle to take off. But yeah, they're really taking their time with the official word on the scrub, which makes me think that it's potentially just some sort of range violation or something, and they actually are waiting for the thing to clear so they can reset the clock. Yeah, could be the case. I hope it's not a boat. That would really suck. Sometimes boats take a while to get out of the range, and they can totally screw up an entire launch just because someone didn't pay attention to the charts of where they were allowed to go and where they weren't allowed to go. But yeah, no throwing blame yet. We don't know anything. This is all speculation. We're still in a scrub condition. That's all we know. The clouds continue to get more menacing as we watch this live stream. We started with a completely blue sky, but now it looks like looks like we're falling into the depths of a storm here. Looks like we're getting some pretty serious oxygen clouds now. That seems to be indicative of a detanking, to be honest. You wouldn't see that if we were just regularly loading. That's a lot. So, that's not a good sign. Yeah, it kind of looks like they are blowing off a bunch all at once there. But maybe it was just temporary. We'll see. Anyways, we will continue to stand by and await further information from Firefly Aerospace. We hope that they get back to us relatively soon with some sort of official word as to whether the launch will be officially scrubbed or if they're still planning to potentially recycle the rocket to try again. However, until further notice, I guess we assume we are in a total scrub, but do stand by for official word and maybe some information about what exactly went wrong. Anyways, stay tuned. And it looks like news came
here at
quickly.
Firefly are reevaluating and looking for tomorrow's launch window now. So tomorrow's launch window is the exact same as today, from 3 p.m. Pacific to 7 p.m. So another 4-hour launch attempt. We're waiting for more confirmation. Well, if you want more information about the reason for today's scrub, Firefly might be updating us on Twitter, but I don't know if it's anything other than weather and whatever else they're working with. As you can see here, look at that cloud. So the good news is, though, that we're going for tomorrow's launch attempt. Again, same time tomorrow. I will reset our stream and get us ready for tomorrow. But meanwhile, I just wanted to say thank you all for watching. I did want to mention that we do, of course, have our Aerospike shirt and lots of...
So it looks like, indeed, they will be resetting, as we expected. So yeah, it must be something to do with, probably something to do with the weather in the end, because as you saw, that was a very scary cloud in the back there. And of course, they do tend to stop launches for things like thunder and lightning and stuff, because that can actually screw with how a launch unfolds. So yeah, looking forward to coming back tomorrow to see if we can witness this launch. So hope you join us again tomorrow. There's lots of stuff to look forward to in that launch. Lots of interesting camera views that you're going to see, and always cool to witness a new piece of technology getting into orbit and seeing more companies getting to this ambitious marker. So do join us tomorrow, and we'll see you then.